Good evening, all. Good evening. You're welcome to the tutorials with from a tiny schoolboy. Today we'll take a look at chemistry review, assignment 7. Chemistry review, assignment 7. If I call you, come out and pick your question. Then we take it up from there. Okay. And I come out. Come and pick your question fast. Fast. Give me. Question what? 4. Question 4 says, helium atoms are chemically unreactive because A, there are no electrons around the nucleus. B, the number of protons equals the number of electrons. C, there are equal number of protons and neutrons in the nucleus. D, the outer electron shell is completely filled. What's the answer? D. What? What is D? The outermost. This says the outer electron shell is completely filled. Is that the reason? Why do you choose D? Can you say one or two things there?
Helium is an octet that is a noble gas.
Okay.
And these things are already complete. The stable gas.
What is the atomic number of helium?
2.
And you say it's octet.
But wait, helium, yes, that's atomic number of 2. But it belongs to group 0 or group 8.
I agree. So why is it that it is octet? Is it octet?
Okay, please read the option.
Do you want to change your option?
Just read it, please.
Okay, I should read the option. Option A says there are no electrons around the nucleus. B, the nucleus of the number of protons equals the number of electrons. C, there are equal number of protons and neutrons in the nucleus. D, the outer electron shell is completely filled.
They are not active. Right?
They are not active again.
Is A.
A says there are no electrons around the nucleus. Is that your answer?
Yes, I will.
Thank you. You can go and sit down. Thank you. All right, so Ada wasn't sure of what she was saying. She came here and she became confused. The answer is actually D. But I ask you a simple question. That means you really actually know it very well. You said octets. Yes, they are inert gas. What is it called? Helium. Helium is one of the noble gases, and reactivity has to do with because if the shell is not completely, outermost shell is not completely filled, that when the atom has want to enter into what? Bonding. True of us? Yes. Either by a certain electron or by losing an electron. And either way, what they want to achieve is octet or duplet. Octet is 8. Duplet is what? 2. So, but helium has 2 what? 2 electrons. So what you want to eat, it doesn't need extra electron. It has already achieved the what? Duplet what? Structure. That's the question I asked you. You became confused and end up taking the wrong answer. All right. Okay. We'll come out and pick your question fast. Pick your question. Give me. Good. Number 21. She went and said, it's okay. 21 says, if I know, I wouldn't have told people, but it's okay. 21 says, come out. 21 says, water molecules are held together by A, covalent bond, B, hydrogen bond, C, ionic forces, D, Van der Waals forces. Explain, come out and explain it. Why do you say hydrogen bond? Sorry.
Because you know that water has a high boiling point. So that hydrogen bond will not make it strong. Like
Continue. Are you done? Huh?
yes.
Thank you. Go and sit down. Chinwe said that the reason why she chose hydrogen bond is because water has high boiling point. See, the question is why water molecules are held together by which bond? It's not the boiling point that made them to have a hydrogen bond. I think it should be the hydrogen bond that made them to have what? High boiling point. True of us. So you got the option, but your explanation is not what I want. What I wanted. Now listen carefully. When I drew the bond between the hydrogen atom and the oxygen atoms that form a molecule of water, right? Good. After that, I told you that there are still we still have two lone pairs of electrons that are still remaining unshared. Can you remember? Now that one formed by hydrogen, two atoms of hydrogen and the two oxygens, right? That one formed is just a molecule of what? Water. But there is also a bond. Molecules of water come together. There's also a bond between different molecules of water. Am I communicating? Now, what is actually between hydrogen oxygen is covalent bonding. I agree. But the one that will now link that water molecule form with other water molecules is what? Hydrogen what? Bonding. Hydrogen bond. All right. Next question. Please, any explanation I made, if you don't understand, please ask question. Not keep quiet, please. All right. Next question. Adoya. Fast. Number 9 says, which group of elements forms the hydrides that are pyramidal in structure? A, group 3, B, group 4, C, group 5, D, group 6. Group what? 5. Why do you say group 5? Explain why you chose group 5. Explain why you chose. You cannot explain. Who can explain that? Nobody. Go and sit down. Thank you. The answer is actually what? Group 5. The answer is actually what? Group 5. Now, you know in group 5, let me use a group 5 element, something like nitrogen, for example now. Nitrogen. Something like nitrogen. This is something like nitrogen. Something like nitrogen. Nitrogen has atomic number of what? Of what? 7, right? Good. Watch out. And this nitrogen, you know they say hydride. That is hydrogen now, right? Now, if you watch now, nitrogen has, we have, this is 7 inside the shell. The innermost shell has 2 what? 2 electrons, right? Followed by what? 5 electrons at the what? outermost what? Shell. Are we together? At the what? Outermost shell. Now, if you take two, are you listening to me? What are you pressing, Nanda? Keep that thing. It's distracting you. Look up. I'm doing something on the board here. Oh? Now, this nitrogen, this one is inside is the what? In the most shell. Now, this outermost shell now has 5 what? 5 what? Electron. 5 electron. Now, this pair, we have 2 electrons here now, right? So this you know that nitrogen in ammonia, nitrogen has what? A lone pair of what? Electron, okay? Now, one is here, and one is here. It forms a bond with hydrogen with one of these electrons, okay? Form another bond with what? Hydrogen with one of the other electrons, and form another bond with what? Hydrogen. So everything is now what? Complete, okay? It's complete. But it should be like this. And even what is here is just a pair, just one electron. This would have been the case if it's only one electron that is only here, right? But because this electron here is a pair of electrons, now there will be a repulsion. The repulsion between this lone pair of electron and this one here that form this bond will be much that it will pull this one down like this side. It will pull them down. You have something like this because of the repulsion. Like charge repel, right? While unlike charge attract. Because of the repulsion, this lone pair of electron will repel these electrons here, and you have something like this. Watch out. See what you now have. Are you there? Now, this is what happens. It will pull this electron, repel them, push them away. They will go down. Instead of staying like this, they will now stay like that. That is why it is what? Pyramidal. It's like a what? Pyramid. Is it clear? It's like a what? It's like what? It's like a pyramid. Where this hydrogen form the base, something like this. Where this hydrogen form the base of the what? Pyramid. Okay? And nitrogen and this thing form the what? The peak. This is why ammonia. So ammonia has what? A pyramidal. I hope you know that this ammonia, I hope you know, has a what? Pyramidal what? Structure. Do you know why methane has a tetrahedral structure? Watch out. Methane. See methane here. Watch out. Here is just one electron. It's like a cross. It's what? Tetrahedral. Because if there's double bond here, it will pull it down. Because it's just a single bond, they just be what? Equilibrium. They just stay like that. So that's why the answer is what? Pyramidal. Now, other ones, just is what? C. V, group 5. Other ones, group 6. Watch out now. Group 6 is between oxygen and what? Example of group 6 is what? Oxygen, right? Oxygen and what? And hydrogen. See what happened in oxygen and hydrogen. Oxygen only is even the worst. It has what? 2 lone pair of electrons. In fact, that's why water molecule look like V, has V shape. V shape. It will pull the bond very far. You see something like this. Hydrogen will be here. Hydrogen will be what? Here. This is how water molecule look like. Then we have two lone pair of what? Electron. This is how water molecule look like. Don't worry, by the time we enter shapes of molecule, you appreciate this. So I'm just trying to, introduce us to it so you can now see what happens. By the time we enter shapes of molecules, then we now dwell into describe this what very well. This is what? Water what? Molecule. V what? V what? Shape. This is methane, right? Or even tetrachloromethane, that's the same thing. Is what? Tetra what? Hydra. This is what? Ammonia. Ammonia, and is what? Pyra what? Pyrimidine. Okay, let's continue. So the answer is what? C. All right. I can't see. Sorry, Chinwe, come out. Fast. Fast, no time. Pick your question. Nineteen says, which of the following statements is correct? A. Covalent compounds would readily ionize in solution. B. Covalent compounds consist of ions. C. Hydrogen bond is formed between a metal and a non-metal. D. Ionic compounds in solution would conduct electricity. I should come again with what? Which of the following statement is correct? A. Covalent compounds would readily ionize in solution. B. Covalent compounds consist of ions. C. Hydrogen bond is formed between a metal and a non-metal. D. Ionic compounds in solution would conduct electricity. What's the answer? No, if you don't know, say you don't know. Don't waste our time. C is what? Hydrogen bond is formed between a metal and a non-metal. Is that your answer? Take you go and sit down. Hydrogen bond is formed between a metal and a non-metal. Between a metal and what? A non-metal. Is hydrogen a metal? Huh? It's okay. It's not the answer. The answer is actually what? D. Ionic compounds in solution would conduct what? Electricity. Ionic compound in solution will conduct what? Electricity. From the name ionic compound, when they come in contact with water, they do what? Ionize and form ions. And these ions are what? They are, according to the work of Arrhenius in prior before electrolysis. That is the basis of electrolysis. Is these ions in electrolyte that will carry the what? Current, right? So in solution, ionic compound, they do what? Conduct what? Electricity. Ions conduct what? Electricity. But covalent compounds, no, they don't ionize in solution. And then they don't even have ions. Covalent compounds have what? Molecules. True of us is molecules, not what? Ions. So the answer is what? D. Cancel, come out. Next question. Come out, fast. Don't waste our time. Fast. Now pick your question. Number 8 says, the weakest attractive forces that can be observed between the two molecules is A. Between two molecules is A. Ionic. A. Ionic. B. Covalent. C. Coordinate covalent. And D. Van der Waals forces. Why do you say D? Van der Waals forces. What do you say D? Because of what? No, I don't. Your book is there. Talk to us. You don't reason. Ganga, sit down. Thank you. I think C. Come and sit here so that not when I call you, people start wasting time. Get your book and stay here. So nobody will block you as you're coming out. Get a book and stay here. Or even here, sir. Better. All right. See, our star girl for the day, or the star boy, somebody that if you come out here, say the correct answer, and be able to explain why that is what? The answer. That's what I want you to learn how to do. You have not go to that level. If you give your answer, be able to tell us why is the answer, why that is the answer, and not the other options, or as the case may be. That's when, even though I know that those all those small, no matter how small, but at least it's something. So you should be able to explain your answers. All right, so the answer is what? She got the answer, but she couldn't explain the what? Answer. The weakest, you have to look at the option given to you, okay? Compare it with all these ones. Ionic is very strong now, true of us. It's very strong. Covalent, very, very what? Strong. Coordinate, same thing. Coordinate is also a coordinate covalent is a type of covalent bond. Hope you know. It's also strong. Then, but one hour is just a weak intermolecular forces. Even self. Do you know? Just simple heat. Just a little amount of heat can do what? Break it. Are you aware? So it's not that what? Strong. So that's why it's weakest. So van der Waals is weakest among these things you are looking at there. Is what? The weakest. So the answer is what? D. All right. Oh yeah. Michael, come out fast. Pick your question.
What if they not ask the strongest?
It's stronger in the question. In the question, okay, but sometimes, but not the type in yes, ionic is it is yes, ionic it is yes. Okay. Number 20. 20 says, state the type of bond broken or melting each of the following substances. But one is sodium chloride. You state the bond broken in sodium chloride when it's melted. State the bond that is broken in carbon 2 oxide. Then bond in silicon dioxide. Then IV in aluminium. Start with sodium chloride. What bond is broken in sodium chloride? Ionic bond, sodium chloride. What of number 2? What of CO? CO. Carbon 2 oxide now,
Only CO is carbon 2 oxide, not carbon.
Covalent bond. You don't know? Hydrogen bond. The SiO unko silicon dioxide unko.
Silicon oxygen covalent.
What's the name of the bond? Aluminium unko. Metallic bond. All right, thank you. Sit down. The sodium chloride is actually what? Ionic what? Bond. Sodium chloride is what? Ionic what? Bond or electrovalent bond. Then carbon 2 oxide has 3 bonds. There are 3 bonds in carbon 2 oxide. The first one is a double bond. The other one is a single bond. That double bond is a covalent bond. The one that is single is what? Dative bond or coordinate covalent bond. So there are 2 bonds that we broke. Anyway, what other bonds are covalent bonds? You need to be more specific. You have what? Covalent bond, ordinary covalent bond, and what? Dative. So that is the bond, 2 bonds there. Even though they are all in big bracket of what? Covalent, but you need to specify. Because anytime you mention covalent bond, what comes to your mind is what? Ordinary covalent bond, right? Sure? So that's why you should be specific, okay? Now, the other one, silicon oxide, we have what? We have covalent bond, but there's something with that one, covalent bond, but it's not a non-polar one, it's a polar one, okay? What distinguishes that with other one is that this type of covalent bond in silicon is a polar type, okay? You know what we mean by polar? Soluble in what? Water, right? Hope you know. So that is not that is not the normal covalent bond, you know, that form non-polar substances. Now, but the one in aluminum is what? Metallic bond. The one in aluminum is what? Metallic bond. Okay.
In cover 2 outside, covalent bond there, see, the non-polar.
Yes.
Which one did you say is silicon dioxide?
Covalent, but the polar. Make someone come out. Pick your question. What are you doing? 24. Okay, 24 says, name the type of solid structure possessed. Go and sit down. Don't know where you can sit down. She know that one. Hey, let us not waste our time. Name the type of solid structure possessed by what? Iodine. Iodine and what? Is it only iodine I wrote? Okay, please add sodium chloride there, please. Add sodium chloride there. Add sodium chloride there. I didn't complete the question. Now, iodine, the structure there is a covalent crystalline structure. Covalent what? Crystalline what? Structure. In what? Iodine. Covalent but crystalline what? Structure. That's what, by the time we go to covalent what? Let's be there. So we don't go far. Covalent what? Crystalline what? Structure. Then, but sodium chloride, the one in sodium chloride is actually crystalline structure anyway, but it's a, you've seen something like this before in your chemistry textbook. When I was in SS1, we did that as a project. I don't know what we do now in your secondary school. We did that as what? Project. We brought orange, small orange, and broom stick, and we did something like this when they were teaching us the structure of these things. Another one is here at the center. Another one is here at the center. They have different colors. One represents chloride ion. The other one represents what? Sodium. So this is a cubic. It's actually what? The officially is called what? Face-centered cubic crystalline structure. Face-centered. It's also a Latin saying. Face what? Centered. Face-centered cubic crystalline what? Structure. FCC. Abbreviation. F what? CC. Face-centered cubic crystalline what? Structure. Iodine is what? Covalent crystal. But this one is what? Face-centered, and is what? Electrovalent. Is what? Electrovalent. So that's the type of structure you see in sodium chloride and what? Iodine. All right. We move. Cancel, come out. No time to waste. Come out fast. Come and pick another question. Question 14 says, a substance is said to be impure. A substance is said to be impure if A, its melting point range is wide. B, it dissolves in water with difficulty. C, it has a low melting point. D, it is colored. C is what? It has a low melting point. Is that your answer? Thank you. Go and sit down. Thank you. She said that it has a low melting point. This question can be is tricky. If you don't know about melting point, you cannot answer that question. See, listen. An impure substance does not have a melting point. That's the first point you should know. If you say melt, if you say point, it means that at a particular what? Temperature. That's the meaning of melting point. What it has is what? Range. What it has is what? Range, because it's composed of different constituents that have their individual what? Melting point. So it will start at a particular point. It will start melting at a particular point and continue melting. Maybe the constituent with the lowest melting point will start melting. But if you look at the mixture, all of them will not do what? Melt. Until all the constituent elements, the final one with the highest melting point melts. That's when the entire mixture will do what? Melt. So it has a melting point range, not just melting point. Am I communicating? So because it will start in that range, the lower limit, that is the lowest melting point is the melting point of the one with the lowest melting point, while the upper limit is the one with highest what? Melting point. It will pass through that stage before that will completely do what? Melt. So it's a range. It's not a what? Point. This is a brilliant question. You need to reason. It's not just what you just answer anyhow. So the answer is what? The answer is what? Is A. Its melting point range is what? Wide. That shows that it's what? Impure. Thank you. Adora, come out. Fast. 16 says, give two characteristic features of boiling. Give two characteristic features of what? Boiling. Oh yeah, your time starts now.
Actually, there's no drill to but
Oh yeah, Amalia, go and sit down. Don't waste our time here. If no, yeah, Amalia, go and sit down. I don't want us to waste too much time, okay? No time again. So let me just answer it so we move on. Now, of course, it's simple now. You can even start from the definition, true or false, and come down. True or false, you can simply say boiling. Number one, that boiling takes place at what? At a particular what? Temperature. True or false? Is a feature, right? Is a feature, right? It takes place when the atmospheric pressure is equal to the what? When it takes place when the vapor pressure is equal to the what?
atmospheric pressure.
Is that not? Eh? What's that? It's okay. Bubble formation is okay. It's okay. I've listed how many now? 2. I said that it takes place at a particular point, right? Then you can also say that if the what is it called? When the vapor pressure is equal to the what? Atmospheric what? Pressure. You can also say that there's bubble formation in doing boiling, right? There's what? Bubble what? Formation. You can also say that unlike, you know that there is difference between evaporation and what? Boiling. Evaporation is a surface phenomenon, right? Who can remember that? Difference between evaporation and boiling. That the evaporation takes place at the surface, right? While boiling takes place in the entire what? Liquid, right? So boiling also takes place throughout the entire what? Liquid. So it's a feature. True or false? It's a feature. I mentioned how many now? 4. Good. You can also say that boiling occurs at a higher temperature in impure substance, true or false? But at a lower temperature in what? Pure substance, true or false? True or false? Yeah, when the substance is impure, the boiling will take place at a higher what? Temperature. It's not true. Kamsi, you're not right what I've been saying here, sis. Huh? Why? I mentioned 5 points now. You not write anyone. Huh? Kamsi, what's going on? I don't like this. It's not good at all. It's not. Others are busy putting substance on something. You are there. You are in front. You're not writing anything. What is distracting you? Please get focused, please. Okay? Please, I beg you. Get focused. Okay, we can leave it at that, so we don't waste time. After you collect what others put down and make up your note, please. Who came here? Oh yeah, Chinwe, come on fast. Pick your question. All right. 17 says a compound U melts at 82 degrees. Huh? Go and sit down. Hey. Okay. Number 17 says a compound U melts at 82 degrees Celsius and boils at 113. What's that? It wasn't mentioned. You see that I mean that one. A compound U melts at 82 degrees Celsius and boils at 113 degrees what? Celsius. If U was found to be insoluble in water, a mixture of U in water could be best separated by A. Chromatography, B. Sublimation, C. Filtration, D. Use of separating funnel. Thank you. Now let's not waste our time. The answer is C. Filtration. The answer is what? C. Filtration. Now let me explain. The question gave you two temperatures. 82 degrees Celsius is the melting point. Then 113 is what? Boiling what? Point. So you don't have to be told that this is a solid. If you heat it at 80 degrees Celsius, it will melt. And you continue heating, right? When you get to the what? 113, to start boiling. Is it not? From solid to what? Liquid to what? Vapor. It's not change of state. So this is the technical question you need to reason. You don't have to be told that it's a what? Solid. As you heat it, when the temperature gets to 80 degrees Celsius, it will melt and turn to liquid. And if you keep heating, when the temperature get to what? 113, it will start what? Boiling. That's the boiling point. So it's a solid. So all this other thing here has no business with what? Solid that is. Remember you are told that it's insoluble. So all these ones say have no business with solid that is what? Insoluble. Chromatography is a solute. True of us. Solute in what? Solution, right? Separating funnel is two what? Immiscible what? Liquids. Submersion is a solid. There are no dissolution here. So the answer is what? Filtration. Once it's not soluble, if you get your filter medium, you filter it out. True of us. Water will go its way. So the answer is what? C. Filtration. This question is all about thinking. Simple. Applying what we have taught, we have done in what? Separation what? Techniques. Simple. That's what the question is testing. So the answer is what? C. Filtration. Now, Michael, I come out. Come and pick your questions fast. Thank you. Number 6. Number 6 says elements P, Q, R, S have 6, 11, 15, and 17 electrons, respectively. Therefore, A, P will form an electrovalent bond with R. B, Q will form a covalent bond with S. C, R will form an electrovalent bond with S. D, Q will form an electrovalent bond with S. What's the answer? D. Why did you choose D? Explain to us. C marker. Go there. Tell us why you chose D. Use the back. P has atomic number of what? Atomic number of 11.
Which one has the atomic number of 6?
6. Okay, so sorry, 6 is P. Sorry. P is 6, sorry. Then Q, do you want to list all the okay. Then Q is 11. Q is 11. R is 15. Then S is 17. Okay.
So, after looking at all the options, I chose that P will form a covalent bond with S because P has the atomic number of 6, which is carbon, and this one has the atomic number of 17, which is chlorine.
Don't name them. Don't name them. Don't. Don't name them. Don't name any. See, don't name any. Just use the atomic number to solve the question. Don't name them. Just forget about their naming. Just use to do it electronically. Tell us what the likely bond is to form. That's what I want to test. Don't use the explain it, but don't use the elements. Just use the number alone to tell us the likely bond that can be formed using electronic configuration. Then tell us. That's when I know that you know the topic well.
This one is lacking one electron.
Okay. Which one is that? S?
Yes.
Okay.
It's lacking one electron, so it requires one electron to be given from this one.
Huh? Allow him now. Allow him now. Please. Allow him now. Eh?
I don't know.
Thank you. Sit down. Thank you. Once in a while, just allow him to finish. Let him do what he has in mind. Do you know what he has in mind? Allow him to finish. It's when he's done, then we know. Remember, this is where we want to see what he did. So allow the person to explain himself. When he finished, then we'll look at what he did. He tried, fine. Configuration, based on configuration, there's a point he made here, but he couldn't sustain the points. He made a point here that this one is lacking electron. It remains one electron to achieve what? Octet configuration. Wonderful. But Elizabeth, he became a kind of confused. Now let's do this thing, please, so we can move to the next question. So we use their configuration and see the likely bond that is obtainable between this and this, this and this, this and this, as case may be. Or instead of wasting our time, let's look at the one they have here. Okay, here they have P and what? P and what? Next one is what? Sit up. This is not how to sit in class. Q and what? And what? S. And next one. R and what? Next one. Q and what? S. And S. Okay, let's look at this thing. Let's look at P and R. P has atomic number of what? 6. So you simply have what? 2 what? 2 what? 2 what? 4, right? 2, 4, right? This is P. Then Q has what? So R has what? 15, right? So we have 2 what? 5. Okay? Now look at these two elements. This one need to achieve what? 2, 8. Hope you know. And this one needs to also achieve what? To achieve what? This 5 cannot go totally. Hope you know. Are you aware? This 5 cannot disappear like that. Are you aware? Then 2. You need to achieve this. This one is looking for 3 to fill up. This one is looking for 4 to fill up. 2 of them have issues. Hope you know. Are you aware? It can work. In Igbo language, in achievement, this one is looking for 4 to complete. This one is looking for what? 3 to, and they can't even share. Hope you know. So this is rubbish. That first option is what? Rubbish. It's easier to do what? Confuse you. Am I completing? Now let's go to the next one. Q and S. Q is what? 11. S is what? S is what? 17. So this one is what? 2, 8, 1. This one is what? 2, 8, 7. This one want to achieve 2, 8, 8. And this one want to achieve what? 2, 8. Because this cannot accept up to, it can't accept. It can easily, the energy to accept is far higher than the energy to do what? Lose this one. So this can easily lose 1. 3 of us. And this one is looking for 1. So two of them can marry. 3 of us. They are complement. 3 of us. So this and this can form a bond. Then what type of bond can they form? Ionic bond. 3 of us. Because ionic bond require transfer of what? Electron. Loss and gain. 3 of us. So they can form ionic or electrovalent bond. So Q and S can form ionic and what? Ionic or what? Electrovalent bond. Let's look at R and S. Can you say, are you following? Please, if you are lost, speak out. Don't quiet. Let's look at R and S. R is what? 15. S is what? 17. Then R is 2 what? 8 what? 8, 5. Then S is what? 2, 8 what? 7. This one need 3 to be complete, right? This one needs 1 to be complete. They are not complementary. Hope you know. So forget that option. Go to the last option. Q and what? S. Q is what? 11. S is what? S is what? Okay, these are the same thing, right? Yeah, so this is equivalent, right? Now let's look at the option. But they now came to the option. The first one, Q and S, they say is what? Covalent, which is wrong. 3 of us. So the answer is what? Equivalent, which is what? Option what? D. Option what? D. Q and S will form a electrovalent bond. But to confuse you, they came to option B and say that they will form what? Covalent what? Bond. So the answer is what? D. I am Mr. come out. Number 12. 12 says the negatively charged particles in an atom is the A, electron, B, neutron, C, positron, D, proton.
Negative neutron.
Neutron. Thank you. Mr. Mo told us in this class that negatively charged particles in an atom is neutron. Mr. Mo, I know here. You so quiet? I'm sorry. When you so quiet about a child is what? Neutron has no charge. Okay, is what? Electron. This would have made you a Stargate today, but you messed it up. Child. Simple question. The simplest question in this review. Child. All right. Oh yeah. Can't you come out? Fast. Pick your question. Question 15 says, which of the following solids are expected to have a relatively high melting point on the basis of the structure? A, calcium oxide. Calcium oxide. II, sodium chloride. III, sulfur. IV, iodine. Then option A says IV only. B says I and II only. C says III and IV only. D says I and III only. What's the answer? D. Why do you say D? Una Fulonya or Maria. Go and sit down. Can't see ever. What is going on? What is going on? Did you do this assignment? Are you sure? Alright. Thank you. So let's look at the question again. Which of the following are expected to have what? A relatively high what? Melting point on the basis of the what? Structure. Calcium oxide has what? High melting point. Okay. Sodium chloride has what? High melting point. That's why you can heat it. You can heat it to sacrifice the what? In solution, you can heat it to sacrifice the what? Liquid, and it will not decompose. True of us. That's why you can use evaporation to do what? Separate what? A solution of what? Sodium chloride. True of us. Now, but sulfur to compare with sodium chloride and the calcium oxide, sulfur is what? Has a lower what? Melting point. Sulfur has what? Lower what? In fact, sulfur says that that's how you even, there's a condition you place it to submit. True of us. It will sublime. True of us. Then this one, what is it called again? Iodine. That one is even the worst. That one is even the worst. Just open it and keep here. It will just do what? Give it time. It will disappear. So the one that I have relatively high melting point is what? I and what? II. So the answer is what? B. The answer is what? B. Adoya. Yes, you come in like that. It's exercise. It keeps you attentive in what you are doing. Becoming even if 20 times. Huh? Oh yeah. To 3 says the bond angle in the tetrahedral molecules such as tetrachloromethane is A, 180 degrees. You don't know it? Child. Who name an assignment? Oh, it's so obvious. It's not good though. Alright, let's go. Let's not waste time. In tetrachloromethane, remember I drew a diagram of what? Tetrahedral structure here, right? The bond angle, the angle between the bond is what? 109.5 degrees Celsius. Sorry, 109.5 degrees. That's the answer. 109.5 degrees. 109.5 degrees. This one here, this perimeter, this one here is 107 degrees. But this one is 109.5 degrees. So let's continue. So we don't waste our time. Oh, yeah, will come out fast.
Okay, this one is 107.
Why people? What you know that you see, you are peeping it through it. Number 2 says, which of the following techniques can be used to show that chlorophyll pigment is a mixture of chemical compounds and not a single colored compound? A, crystallization. B, hydrolysis. C, sublimation. D, chromatography. Why D? The reason is simple. I just wanted to say it. Yeah. If you can't say it, sorry, you don't know it. It's simple. True of us. Simple reason, just say it. We did chromatography in this class, so just say it. Simple. Is what? The what? Pigments. Okay. We do what? Confidence, lack of self-confidence. She mentioned something now. I want her to just conclude. She's laughing as if she's not sure what she's saying. Pigment did what? Huh? You don't know. If you don't know, go and sit down now. Child. She has lost her stargate ship now. Simple thing. Articulate your point well. See, whenever you hear pigments, what comes to your mind is what? Chromatography. Am I communicating? Because all those color pigments, they are solutes. What to get a solute and keep it, they will separate. Whenever you hear pigments in terms of what? Chromatography. Separation techniques. What comes to your mind is what? Photography. So I said that she won this thing. You answer Roman for. You want confidence? You speak with confidence. Speak with confidence. This is what it is. You stand by it. No, that's what it is. No, that is what it is. It's pigment. Once you come to pigment, you go to graphy. Cure ED in our boyale ever since. In our boyale. Chlorophyll is made up of what? Pigment. True of us. Simple. In our boyale, you call pigment. Did I confused? You don't know how to link your point. Link that pigment to what? Chlorophyll. Bring it back to what? Chromatography. Case closed. You have lost your stargate ship. What can I do? What? No, you can't. Bonus. Is that what you mean? No bonus. Don't worry. Do you know why? You are sitting down there with your book. That's why I won't take it. You are sitting down there with your book open, but the person standing here is not with our what? Book. So why would I give you bonus? No. And even you are not with anything, I can give you bonus. All right, let's continue. Michael, I come out. Pick your question. Okay, number 10 says, is that what? It's alright. You can go and sit down, no problem. All right, let me solve number 10 so we don't waste our time. Any day you want to answer bonus, let me give you a secret. Any day you are prepared for bonus, do you know what you will do? Any day you want to answer bonus in this class, once review starts, close your book, keep it aside, go to this side and stay. If you can do it, then any bonus I'll just be giving it to you. You may win up to 5-10 prizes that day. So is it okay like that? So any day you want to answer bonus, just close your book, go there and stay with only your pen. Don't do anything. Any bonus, Nami said go disturb you with enough bonus to answer. But not when I sit there with a book, look at it. You are saying bonus, no, it's wrong. All right, let's do this. Did you see a nuclear what? Reaction. Is a what? Nuclear what? Reaction that involves subatomic what? Particles. It's not just atom now. You know the difference between nuclear reaction and ordinary reaction is that nuclear reaction involves the atomic what? Particles inside the atom. But ordinary reaction just involves the atom itself, true of us. So that's the difference between when. So that's what proved that what made the Dalton's, the first part of Dalton's atomic theory. That's what made it what? Not to fly. Can you remember? Good. So let's do it. We have what? This is n plus what? X. Plus what? This is simple. Look up. You just use your normal way of balancing equation, but what you do is this. Look at the number of moles, okay? Also look at number of what? The mass number and the what? Atomic number. They must be what? Balance. Okay? Now here, X is here. We don't know what is X, okay? But let's look at the products. We have oxygen 17. This is oxygen 17. This is an isotope of what? Oxygen. Is an isotope of what? Oxygen. Oxygen what? 17. This is what? Nitrogen, right? Now look at it. You balance. Make sure that this is hydrogen. An isotope of what? Is hydrogen, right? Then there's an isotope of hydrogen that has 2 here. 2 as the what? Atomic mass. True of us. What's name? The what? Deuterium. Okay. The one that has 3 is what? Tritium. Good. Thank you. Now see what it is. Simple. The atomic number must be balanced with what is here. Okay. Then the mass number must also be balanced with what is here. Look at here. Look at the product. Let's check the total mass atomic number here and balance it with one here. Here atomic number say total is what? Which one is atomic number? Which one is mass number? Down. So what is total atomic number here? 9. Here is what? So what should be here to make it 9? Here should be what? 2. Good. Now let's look at mass number. Who is not following? Are you following? Let's look at the mass number. Total oxygen 17 and hydrogen 1. 17 plus 1 is what? 18. So the total mass number here on the product side is what? 18. Now let's look at the one we know at the reactant side is what? 4. So what is the difference? 18:4, right? So 4 should be here, right? For us to balance it, right? So that means here is what? 18, 8 is balanced. So which atom has this? Which element has this? Or what? Helium, right? Is what? Helium. So X is what? Helium. So the answer is what? B. Helium atom. The answer is what? B. Helium atom. Is it clear? Huh? Yeah. Good. Make someone come out. When you are done, come out. Make someone pick number 11. The following are mixable with water. Number 11. The following are mixable with water except A. Ethyl ethanoate, B. Methanol, C. Ethanoic acid, D. Methanoic acid. A. Ethyl ethanoate, B. Methanol, C. Ethanoic acid, D. Methanoic acid. Why do you say A? The following are miscible in water except.
It's A because miscible is the word something that can accept another substance.
So why did you choose A? Why didn't you choose other ones?
Because other ones, if you use them with other elements, maybe one, something might support.
We are busy discussing. She have been talking. You didn't hear what she said. It's not good though. Oh yeah. Again, explain again.
I feel like miscible, like when an element can affect another element to mix together. So why I do not use others is because maybe when other elements or substance or particle mix together with it, explosion might occur or it might burn.
Una Folonia, Omalia. What's the makia? Did this assignment? Una Folonia, Omalia. You guys see, no problem. Let me help you. You've tried. No, you cannot help her. It's not what? It's not what?
It's not
Bonus. Oh yeah, I have talked. Let's hear you.
The reason why A is the answer is because it is others, like they are heterogeneous.
How? You know it. I talk. Let's hear you.
It's not capable of separating the Coulombic forces that hold the molecules of water together.
Why?
Because it can't. Because so which kind, what kind?
Why now?
Don't ask me why I told you. Don't ask me why again.
Why? Why can't it? You understand the question. You are still running. It's very good and you just did now. Hit the point. There's a primary reason why it happened. Why it cannot be mixed with water. That means it's not polar now. It's not there. Why it's not polar? That's the point.
Because it is hydroxyl. It belongs to hydroxyl.
Oh yeah, Amalia. And that. She mentioned hydroxyl. But I'm gonna how to put the hydroxyl. Watch out. Others, listen carefully. Others, carboxylic acid. Anyway, we are not done organic chemistry, but we are just preparing our mind towards that. It's okay. At least she did something. Kedafia, Chinwe. At least she tried to do something. But she finds able to articulate what she researched. That's her issue. Now, the issue now is based on the functional group. These functional groups now. Okay? These functional groups now. Now, if you watch this one, carboxylic acid, they have COOH. Sorry, I thought I was writing on the note. This one has what? C what? OO what? H. Carboxylic acid, methanoic acid has it. Which one again? Ethanoic acid has it. Then methanol has OH. Do you notice something here? If you break this one down very well, you have something like this. You have something like this. Okay? So this one and this one, they have what? OH, hydroxy group. So they can easily form what? Bond with what? Water what? Molecule. Okay? Remember? Hydrogen bond, remember? They can easily form bond because that's why ethanol is soluble in water. Alcohol. Because of that OH group, the functional group, they can easily what? Bond with water and they, get miscible. But the other one cannot. He mentioned hydroxy group, but he didn't know he was even giving the hydroxy group to ethanoate. That what you said now. I don't know you could hear. In Aguia from Guria goes in Tizia and the end. That's why I said you researched it, but you didn't read what you researched. Anyway, it's a good step to the right direction. So that means these ones are polar, but the other one are not what? Polar. By the time there's what is called dipole, this thing. But let me not go there. By the time when we go there, I'll have time to discuss it. So this one is polarized. It has positive dipole, the negative one. They can easily bond with what? Water molecule and get what mixed. But the other one cannot do that. It doesn't have such. So he is non what? Polar. Alright. Sorry about the way I teach. I teach from the first principle. I want my students to know whatever they are saying with from the first principle, not just to know that this one is polar, you are not polar. When question is twisted, you wouldn't know where to start from, because question can be twisted. All right, so next person is who? Comes here, come on, fast. Fast. 13 says, write 3 subatomic particles with their corresponding relative masses. 3 subatomic, Are you serious? Offered, you don't know it offered. Wow. Okay, what are the 3 name them. The 3 you know. Proton, neutron, and what? And you don't know their masses in your head. Relative mass is not their. See how you're saying it with confidence. You don't know. Like I can see, you're saying with confidence. I don't know. Yeah, I don't know. It's okay. You can see that. It's okay. But it's not good. You should know it in your head. It's not your paper that will write it for you in exam. Is it your paper that will write it for you in exam? It should be in your head. After doing research, put it in your head. That's the way to go. Who knows it? Oh yeah.
Protons 1.008, 1.007. Neutron is 1.008. Electrons 5.45 times 10
You are telling me the absolutes. I mean relative. When you compare this to this to this. Anyway, let's not. You know that relative is not the same thing with what? Absolute. Hope you are you aware? Now let me tell you the difference between relative. If Chinwe is 20 years and you are 40 years, if Chinwe is 20 years and you are 40 years, your age relative to Chinwe's age is what? 20. Okay? Just simply 20. 20 is to what? Sorry, 2 is to what? 1. Is it clear? Is it clear? When you talk of relative, you talk about the ratio. Am I communicating? Am I communicating? So the relative masses are proton is 1. Proton is 1. Proton is 1. Neutron is 1. Electron is what? Approximately 0.0005. That's the relative what? Mass. Now, call that thing you call. Let's see whether it's true. You call that thing you call. Let's calculate and see whether it's true. You see that proton is what? 1 point what? 00 what? How many zeros? 7. 1 8. 1 point what? 07. Another one is what? Neutron is what? 1 point what? 00. 008. This one is what? 5 point what? 5 point what? 36 point what? Minus what? 4. 36 point what? Minus 4. Okay, look at this now. Look at this now. Let's find the ratio. This is the absolute, as you said. Let's check their relative. You find the ratio of this to this to this. That's what you mean by what? Relative. Okay? And to do that now, we can divide both sides by 1.0007. Okay? And see what it will give us across. This and this will give us approximately 1. Hope you know. Hope you know. Then divide this by 1.007. What will it give you? Divide 5.44 times 10 square minus 4 by 1.07. What will it give you? Should give you approximately what? Fast. Divided by 1.007. That is approximately what? 0. What? 00 what? Efulia? This is their relative, okay? Relative what? Masses. Is it clear now? Good. It's a ratio. This to compare with this. Compare with what? This. Okay? Good. Oh yeah. And I come out fast. Yes. It's Chelsea that came here and told us that he cannot take others. Fast.
But this one is involved with all these atomic, subatomic, monatomic, and atomic.
Which one is what?
I'm not talking of atomic, subatomic particles. I'm talking of which one, all these monoatomic, diatomic.
You're talking about atomicity. That was a different thing. When we get there, we discuss it. You're talking about atomicity.
18.
What? 18. Okay. 18 says List 3 uses of fractional distillation in industry. Thank you. Can I see now? Who else knows other uses of fractional distillation in industry? Who else knows? Someone read for what it is. Don't know what. Read what it is. Read now. It's here.
For separating acetone from water.
Separating what?
Acetone from water.
What else?
To separate different components of crude oil.
Good oil. She has said that one.
To obtain different gases from the air.
Gases from the air. Okay. Separation of liquefy what? Air. Thank you. Next one.
That's right.
Is that what you did, Michael? What did you do?
So I said purification of water by separating
Purification of water. Okay.
Separation of organic compounds.
Okay.
Separation of liquefied air.
Liquefy air. Component of liquefy air. Is that what you did? Good. All right. Next person, fast. Let's finish it so we can fast. Pick your question. Pick now. Number 22 says, states the type of intermolecular forces. You know that one? Hey, now wow. State type of intermolecular forces present in hydrogen fluoride, argon. Who did it? Who? The type of intermolecular forces present in hydrogen fluoride and argon. Let's start from hydrogen fluoride. Who did it? Miss Alma. Is where? I agree. London what? For what? What's the under name for London the dispersion force? What else? Van der Waals, thank you. Van der Waals. You know, this is not how they pronounce it too. That is the German listener. I mean, I don't know how they pronounce it. We pronounce it as if we are speaking English. That is not. I think one. I don't know how to pronounce it, but it's a German name. Yes, that is not the way. That is, we are using English. We are doing it as if it's English listen, but it's not how to. It's a German listen. So you said, Mr. Omar, say what? What are you doing? Is it okay? Hydrogen fluoride is hydrogen bond, and what again? Argon is what? One of our forces, right? Or London dispersion what? Forces. Thank you. Michael, come out. Pick your question. Number 7. 7 says, water has a rather high boiling point despite its low molecular mass because of the presence of A. Hydrogen bond, B. Covalent bond, C. Ionic bond, D. Metallic bond. Why? So how does it contribute to the high boiling point of water? No, I'm listening. I'm talking.
It's higher is like between one of the factors in one of the proteins in the body and one of the electrolytic items in the body. Because of the hydrogen bond, it's makes it harder to.
Thank you. You try, but it's not smooth. I want a smooth answer. Very, very smooth answer. Just the way you did in that biology. You were hitting it, as in you were hitting it like it was just moving smoothly. I like smooth answers. I think I explained this today. I explained it today. I explained what? Today. It's because water molecule has what? Two lone pair what? Electron. So they to form one molecule of water, four hydrogen bonds. 4. So you after breaking that one, before you see that it's not, it will, the temperature, at least the temperature will be high to compare with the one that has small, just one lone pair, or those that don't even have any a lone pair of electron and shared one. Okay, am I communicating? Now you know that the one that doesn't have lone pair electron, the shared one is just there in the covalent bond alone. True of us, they will just break. But this one, what has a lone pair, have 2 lone pairs that will form. Each molecule will form 4 different bonds, hydrogen bonds. So that's what makes the what? Higher. Okay? All right, thank you. Oh yeah. Meso, come out. Pick your question. Thank you. Number 5. Number 5 says the periodic classifications of the elements is an arrangement of the elements in order of their A. Atomic weights, B. Isotopic weights, C. Molecular weight, D. Atomic numbers. Why? Because what? How is it? Okay, state your periodic law for us.
Periodic law states that the properties of an element is the periodic function of the resistance.
Of the what? Of the what now? I don't know what they're saying.
State that the
What?
atomic number.
Can you hear one?
Oh, I know it's not.
No. That's don't that again. It's wrong, please. It's wrong. And with her, allow her to talk, please. That's wrong. She said the law and today she didn't know what to explain that I know. I know what. Ask a question. Answer your question. You are telling me you know now. Yeah. What do I know? I don't know.
I know it.
You know it, but you couldn't answer it now until she mentioned it.
I'm waiting to.
Okay, you are recording it. Thank you. Sit down. No, I didn't get it. Sit down. Please, when somebody is out here, please don't contribute. It's not a contribution session. Don't allow the person to talk. Even if the person is talking nonsense, allow the person. Please. When the person is done, you go and sit down. I will explain it. The person will understand it better. If you are allowed that she maybe who knows? We can what here? Even though the gift that we give is small, but it's something. Allow her to talk. It's not a good thing. Okay. Actually, according to who proposed atomic numbers, I mentioned them here in our last class. I mentioned them in our last class. Let me do that. Actually, listen. I mentioned it in our last class.
John Dalton.
John Dalton. Who? Huh?
Rutherford.
No, I mentioned it here. Huh? You see, I don't mention it. How? No, that's wrong. Don't say I didn't mention it, because I know I mentioned it. Don't say I didn't mention it. I mentioned it. I say we'll continue from there in our next class. We'll talk about, before I run down all these names. Maybe you say you not put it down. Not that I didn't mention it. Didn't I call Moseley here? Moseley, I call that name here. Atomic number. It's okay. That one is just, he's the one that actually, proposed the issue, the atomic number, and doing periodic, and if you see the periodic table now, elements are arranged according to the atomic numbers. Okay? Who? Okay, the answer is what? D. Oh yeah, see who you blame. Nah, blame me for talking. Oh yeah, because I said don't help anybody. Keep quiet. Allow the person to talk. And you're fond of that. Why? You did that thing again last time. I warned you today. You said it. I want it again. You don't even know when you do it. It's wrong. It's very wrong. Very, very wrong. It's not good though. Stop it. It's not a good thing. All right. Next person. Cancel. Come out fast. Okay. Your name is Chimichi. Number 3 says, which experiment led to the measurement of the charge on an electron? I mentioned this in our last class. A. Scattering alpha particles. B. Discharging tube experiment. C. Oil drop experiment. D. Mass spectrometric experiment. What's the answer? C is what? Oil drop experiments. Let me know whether you know it. Who did the experiment? What is the person's name? J. Thompson. Onya Amalia. Can't you ever? I said this in the last class. I mentioned it in the last class. That's why I give them. You can't see you. Give them this. Oh yeah, we'll start here. Yeah, not to bomba. No, she's not coming to class. But as the amount I don't know what's going on. You can see. Bring back our cancy. Hashtag. Bring back our cancy. Please, if you go to your Facebook, bring back our own cancy. Cancy, come back, please. Will you come back? Will you come back? I beg you, please come back. Now sit down. And who knows them? R.A. Melekan. Thank you. R.A. Melekan. All right. Oh, where you go? Get one here. Get what is it? Okay. Mba. Kemetiria. Okay. Don't worry. I can answer the question. Then who is the next person? Ada. Hey, come on. Come out now. No book. No, come. That's why it's not number one. Come and say it. In what year? Obulu your log. Number one says, in what year you be our star girl for today? Everything will come back to me. Come here. The question says, the dissolution of common salt in water is a physical change. The dissolution of common salt in water is a physical change because A, the salt can be recovered by the evaporation of water. B, heat is not generated during mixing. C, the salt can be recovered by crystallization. D, the solution will not boil at 100 degrees Celsius. B is what? Heat is not generated during the mixing. Is that why it's a physical change? Explain. Let me understand what you mean by that. Explain. Let me understand what you mean by that.
I think that in physical state, is reversible, and a solution, a mixture of salt and water is not practically, heat is not involved in it, and physical change does not, there's nothing like heating. And once heating is involved in any changes, then it comes to be a chemical change.
Okay, thank you. Now, there's something I want to say here, please. I want us to know how to answer questions. Answer jam questions. If you see jam. You see jam. Hey, if you are preparing jam, there are 2 things you will know. 3 things. One is to read something. Read it. As you cover the thing you are meant to cover. Cover your syllabus. If you want to make jam, the first thing is to, by yourself or not by all this. If you want to do it, sit down by yourself and write the jam and make it by yourself. Then, first step is to cover the syllabus. Cover what you are meant to do. What? Cover. The second one is to retain it. Make sure that you retain it. Then, third is to make sure that you know how to answer their what? Questions. Are you aware that jam can give you options? Jam can give you options that are the same thing. I'm coming down. Jam can give you options. If you look at the option, that option they give you, that is true of the question. But they want you to answer it in the context the question is being asked. And also with relative to other options, which one is the most what? Appropriate. That's what jam is looking for. If you go into enthalpy change, whether it is endothermic, by the time we do heat change, you understand what I mean. Whether it is endothermic or exothermic, it may be, heat may not be generated. One, it may also be generated, but that is not the main thing. What makes it, what they want to find out is which of the options makes it a physical what? Change. It's because you can recover it. What? 3 of us. That's what makes it what? A physical change. You may see option that say that solid chloride is white in color. The option. Or you may see option that say that solid chloride dissolves in water. Doesn't dissolve in water. It dissolves. But is that the answer? Is that the reason why the physical change? Yes. Solid chloride dissolves in water. But that is not the reason why it's what? They may be right for you. Solid chloride tests salty. Doesn't it test salty? They may tell you that option that solid chloride can be gotten from seawater as an option for you. But is that why it's a physical change? But if you don't know it, once you see that seawater, you rush and take it. You tell yourself, solid chloride is gotten from seawater. But that is not the answer. I don't know if what I explained now makes sense. That means before you answer jam question, secret number 1, Go through all the what? Options. Go through all the options. Don't just allow your eye to see one option and you take it. No. Go through all the options. Relate the options to the questions and choose the most appropriate what? One. Simple. This question now is a typical example of that. Is a typical example of it. So I think with this we have come to the end of our what? Reviews. So no star girl emerged today. Child. Who are you? You are busy telling me what I don't know. Ask a simple question. You can't link up your points. After doing your work, read it, digest it. All right, thank you very much for your attention. God bless you.